Welcome to our Super Nova 14 alignment video. I'm Cameron with CanCam CNC Machines, and we're going to show you everything you need to know to get your Super Nova aligned. A quick walkthrough of everything we're going to cover. We're going to start off with a few disclaimers, and then we're going to move on to the tools that you're going to need to align both of your lasers. Then we're going to go through a tour of the machine, showing you all of the mirrors and locations and terms that you need to know. Then after that, we're going to move on to tests. We want to test to make sure we're only going to adjust what we need to adjust. And then after the tests, we'll go through the alignment of our first laser, and then we'll continue on through the alignment of our second laser. So some disclaimers before we dive into everything. We're going to start off with safety. Safety is, of course, very important. With lasers, you do have to worry about fire hazards, so we're going to be using tape as some guidance to help align our lasers, and you'll want to layer that tape significantly 4 times to prevent fires. Of course, fires can happen in a variety of ways, so have a fire extinguisher nearby just in case. Make sure that if you're burning anything, you have proper ventilation. Make sure that you're not touching any of the electrical wires while the machine's powered on. And also just watch out for general pinches and putting your arm in the beam path and for burns. Keep in mind that this machine in this video may be different from the machine that you have. There may be small components that have slightly changed, or additional components or components missing compared to yours. On top of that, before you go and begin your alignment, you'll want to make sure that your honeycomb bed is level to the gantry of the machine. And lastly, you only want to adjust what you need to adjust. So we're not going to adjust the tubes if we don't have to adjust the tubes. We're going to show you how, but you may not have to do that. So don't necessarily go right back there and start moving your tube around. Moving on to the tools you'll need. An Allen key set, a Phillips head screwdriver. This is a prototype that we're working on that's going to help us align it. We'll release the drawing files for you for this. You'll need some green masking tape, or white masking tape is fine too. This is a small square of 1/2 inch acrylic. It's just a scrap piece. We're going to use that later. And here's a triangle key to unlock the side panels. So just to show you how to get access to all of your mirrors and both of your lasers, at the back here, our middle panel has 2 locks on them. We're going to use the triangle key to unlock it. And then that just folds down, and we have access to our CO2 laser and our RF laser. But the side of the machine here, we're going to open up this panel. There are 2 locks. And then it just folds out. And you lift up, and it comes free. We'll just leave this here for now while we move on to the second panel. For this next panel here, there's 3 bolts. You're going to take your Phillips head screwdriver, and there's a bolt up here. There's a bolt down here, and then around the side here. At the back, there's the 3rd bolt. So this just tips back like the other panels, and you lift up, and it comes out. Here we have our first mirrors. So for the glass CO2 tube, you have mirror 1 at the bottom, and then for the RF laser, there is a mirror behind this panel, which we have to remove with an Allen key. There's 4 bolts holding this in. Depending on your model, it may be different, but there's a bolt here, and a bolt at the bottom, and a 4th bolt at the bottom on this machine. I've taken off the panel here, and you can now see mirror 1 for the RF laser. Directly above mirror 1, we have mirror 2. Mirror 2 can be adjusted here, And if you need to remove that, there are 4 bolts holding that in at each corner. There's one. Mirror 3 can be found further down the side, here on the left side of the gantry. And inside the machine here, we have our gantry with the 4th mirror at the laser head here. So we're going to turn the machine on now to do some tests to determine what we need to adjust. You'll notice the Super Nova has a lot of fans, so it's going to be a little bit loud when we turn it on. Those fans help ensure that the machine stays cool, that the RF laser works efficiently and doesn't overheat. Alright, so we're taking our masking tape here and I'm layering it 4 times at the very least. I think I have a 5th or a 6th here, but that's okay. I'm going to put it over the entry point to the 4th mirror. And then I'm going to do a 4-corner test for each of the lasers. So that means bringing the laser head to each corner. So here, first corner, we're going to go back to the 2nd corner and 3rd corner, and every corner we're doing, we're going to fire a laser pulse. And we'd go to the 4th corner, and after the last pulse, we bring it to the middle, and we're going to compare where all of our laser beams hit. So before we fire the laser, we do want to make sure that our controller has the right settings in and that we know which laser we're firing. So with the Super Nova, to select your specific laser, there is a combination key. So to select your laser 1 is the CO2 glass tube. We hit shift focus, and that programs it that when we press pulse, it's going to fire the CO2 tube. And if we wanted the laser 2 for the RF laser, we press shift Z plus, and that gives us access to fire the pulse for the RF laser. Now, before we fire those, we also want to make sure the maximum power is set appropriately. So the combination key to adjust your power is shift Z minus, and we're going to go through these and reduce all of them to around 40%. Okay, so we're going to go to each corner and fire a pulse. We're doing laser 1 first. So there's 1 pulse. I'm going to take a glance at the tape every once in a while to make sure it doesn't catch on fire. We're at the 2nd corner, another pulse. We're going to the 3rd corner, doing the 3rd pulse, and then bringing the laser to the last corner, and we'll do 1 more pulse, and then bring the laser head to the middle of the bed, and we'll take a look at how it turned out. So, looking at this here, it's not quite perfect, but we have decent alignment of laser 1. Okay, so I've put fresh tape over the mirror 4, and I'm going to do the same exact test after changing to laser 2 on the control panel. So I'm coming to the 1st corner now, do a laser pulse there, and then I'm going to go to the back corner, do a laser pulse there, going to the other corner, another laser pulse, and to the 4th corner, 1 more pulse, and moving it to the middle of the bed, and we'll check out our alignment. So again, it's not perfect, but we have decent alignment for laser 2. Okay, so we tested both of our lasers, and the pattern is really going to show you what you need to adjust. So if it's a perfect circle, then after all 4 corners, it means they all hit in the same exact spot, which is our goal for alignment. Now, if it's more of an 8 or an egg shape, that means your alignment is slowly drifting. And if you see 2 separate circles, maybe even 3, 4 separate circles, that means your alignment's really bad, and you're probably going to need to go back to mirror 1, mirror 2, maybe even the lasers themselves, and adjust there if you can't get the alignment out of it at the other mirrors. Now, if you do get a perfect circle at all 4 corners, but you're experiencing alignment issues, your next possible location, and it's a lot easier than adjusting the mirrors, is the nozzle of the laser head. That would be your mirror 4. It's likely that your laser isn't going through that nozzle. So last test we're gonna do is fire one of each of the lasers at the same piece of tape with the laser head in the middle, and we're just gonna watch if they land in the same spot. So I'm going to do the RF laser first, and then I'm going to check that and try to memorize where that is. You can also use a permanent marker and draw a circle around it. And then I'm going to fire the CO2 tube and see if it lands in the same spot as the RF. So they're fairly close, but not quite perfect. I'll set that there. It actually came out pretty distinct. So based off of the results that we got out of our test there, we will not have to go back to the laser tubes at the back and make adjustments. This is fairly close to making it through the nozzle perfectly. So we would probably go back to mirror 2, mirror 3, and adjust those and check those, and then finish it up at mirror 4. And this is only for our case here. We are going to continue on and show you every area that you may need to adjust if you do have to go back that far. All right. Apologies for the additional volume from the fans back here, but yeah, we're at the back of the machine. We have our Allen key set, and we've also made a custom Allen key here because we may need a very short one. Now, we're going to recommend that you don't actually adjust your RF laser location. It should arrive exactly where it needs to be. And we're going to base all of our adjustments off of where the RF is as it is, and we'll align everything else to that laser. So you'll have to say you did want to adjust it, maybe push it in, angle it a little. You can do that. You'll need your Allen key set and possibly a short Allen key. So there's 8 bolts that are holding it in, and an additional 6 that kind of add some pressure to it. So there are 4 bolts on each of the legs that stand up the RF laser. Those just need loosened, and if you can't get your Allen key in there, you may have to find a shorter Allen key that you can get under the glass tube. On the exact leg, there's an exact same setup with 4 bolts, and you just loosen all of them, and you can push one side in, you can pull one side out, you can push the whole laser left, you can push it all the way right. That gives you a little more adjustment if you need to. But at all costs, try not to adjust it unless you really, really need to. So we're going to start off at mirror 1 here. And we need to have mirror 1 for the RF activated. So I'm going to walk over to the controller and hit Shift Z up to move this in. To align mirror 1, we actually have to remove mirror 2 so that we can fire the beam at a piece of tape here. So we're going to remove all 4 bolts. So we've taken the bolts out and this just lifts up, and we're going to set that aside for now. So we've layered a grouping of tape here that's a little wider than normal, and we're going to place this over the opening that we created, and then we're going to fire the RF at it and just make sure it's generally in the middle. So you can see there is a small burn spot coming through, and it seems to be in the middle there, which is good. If we lift it up, you can see it was pretty much in the middle of our grouping of tape. So we should be good to go to move forward with the next step. So if your tape was significantly out from center of the bracket here that goes up, and that would be significantly near one of the sides, maybe bouncing off the metal, then you would want to adjust your mirror early on to bring it more into the center of that. Because we're going to move on to our next tool here to help align this axis here. So aligning your laser is going to rely on 2 things. You need a near shot and a far shot. So right now on laser 1 and above that, there's only a place to mount the tape at a near location. So what we've created here is just a prototype. We're going to use this to basically align that near and far burn location. Right now we're just calling this the Mirror 1 Extender 9001. And we're going to provide the drawing files if you need it so you can create your own. And we'll likely improve this as time goes on. So how this works is we put a piece of tape on the bottom bracket, and then we slot this into the holder here, and we fire the laser. And then we take this out, we actually pop this tab off, we would flip it over, put it back on, and now instead of putting that at the bottom, we're actually going to flip it over in the same orientation and then slot it in, and now the tape is at the top. So what we've done is we fired a laser beam at the bottom, and then we're going to fire a laser beam at the top, and we'll see where those 2 positions line up, and we'll adjust the mirror accordingly. So we're going to remove this bottom one so we can get a piece of tape on there. And you may want to put 2 pieces of tape depending on your laser. For the RF, 1 piece might be fine, but I'd recommend layering it a few times. For your CO2, you definitely want to put more. So we have tape on there. We're going to slot this back in with the tape facing down here. And that snaps in. And then we're ready to add this into the bracket. So we're going to slide this in at an angle there and let it drop in. You'll see this bracket here actually stops it from going any further down. And this is where we can fire a laser beam. So it hits at the bottom here. And after that, we'll want to walk over fairly quickly and make sure it doesn't start fire. So we're just firing a pulse of the RF. Okay, so we're going to pop this out now. You can see there is a laser mark there. And we're going to try and not to remove the tape or mess the tape up. And we're going to flip this over and slot it exactly where it was. And then we're going to now put this in the same orientation that we had it before, except the tape is at the top. We're going to drop that in. And we'll fire the laser again. So we've taken that out after firing both near and far shots of the laser. And you can actually see that both are hitting in relatively the same location. So our RF is pretty good. But if it was in a different location, maybe 2 beam hits, you may want to adjust your alignment for mirror 1 of the RF. So to explain how our mirrors work and how to align them, you have 2 adjustment screws here. These each have their own jam nut on them that locks it into place. And then you have 2 screws here with springs under them to add pressure. You typically don't need to adjust those screws. To adjust front to back, you're going to use the knob here that's in line with the screw below it. So this one here is in line, so that would adjust front to back and pivot off of that. And then to do your left and right here, you have the adjustment knob and that screw there, so that's going to be your left to right adjustment. Turning this clockwise is going to move the mirror angle to the right. Turning this counterclockwise would turn the mirror to look to the left here. Turning this one clockwise would cause the mirror to aim down. And turning this counterclockwise would cause the mirror to turn up. So if we wanted to adjust this mirror, let's say our left to right here was a little off and we needed to move the second beam backwards towards us here, we would turn this knob counterclockwise and it would move that mirror angle back towards us here. If the second beam fired was a little bit to the left here, we would bring that back. We want to bring that back to the right, so we would tighten up this bottom one clockwise until we get the beams to hit in the same spot, near and far. So we're moving forward with the RF laser before we're going to anything with the CO2 tube. So we're going to install mirror 2 back onto its holder, and we're going to put all 4 bolts back in, and then we're going to align the RF laser across mirror 2. So moving on to aligning mirror 2, we're going to get 4 layers of tape, and we're actually going to place that over the holder for mirror 3 on the left side of the gantry. And then what we're going to do is fire the laser with mirror 3 right up against mirror 2, and then we're going to travel the gantry all the way to the other side and fire the laser at the far location. Okay, so I'm moving the gantry to the back of the machine. I'm going to fire a laser pulse, and then I'm going to move the gantry to the front of the machine. I'm going to take a look at the tape, see where that first laser pulse landed, check the tape to see maybe it caught fire, and then I'm going to get ready to send the second laser pulse through and verify the difference between the first and the second one, the near and the far. So we've gone and written each laser hit. So number 1 is our near shot, and then number 2 is our far shot. So we know that we need to adjust the far one to the left, and it seems like the up and down right now is pretty good, so we should be okay there. So at mirror 2 here, we need to adjust the alignment so that the far beam goes to the left. So I'm going to loosen the lock nut on this and trying not to turn the knob too much. And then maybe try a quarter turn and see what happens. So I'm gonna go about a quarter turn, and we're gonna check how our alignment is now. So I've put a new slice of tape on there, and we're gonna move the gantry to the back. We're gonna send a laser pulse through, and then we're gonna move the gantry to the front. I'm gonna walk over, check where that first near shot hit, and then I'll walk back here, send another pulse, and we'll compare both pulses. We've done our near and far laser pulses, and it turns out that that quarter turn was perfect. They are landing in the exact same position. So now I'm gonna go back and lock up the jam nut on mirror 2, and then I'll verify this again, because sometimes when you lock in those jam nuts, you actually lose the alignment. We're going to adjust mirror 3 now, which is on the left side of the gantry here. But to adjust that, we have to put our tape over the laser head entrance here. So again, just as always, four slices, 4 layers of tape, and then we'll fire a near pulse on the left side, and we'll send the laser to the right side and fire a far pulse. This is good to do when the gantry is approximately in the middle front to back space of the machine. We're gonna move the laser head all the way to the left side. We're gonna send our first pulse through, and then we're gonna move it all the way to the right side, and we're gonna send our second pulse through. And then we're gonna compare where the first one landed versus where the second one landed, and we'll adjust our alignment based off of that distance. So we've done our first pulse and then our second pulse here, and they've landed approximately in the same location, but on the second pulse, you could see that it actually burned a little bit higher, and the burn pattern, because it's such a long distance, is gonna look a little different. So it is a little darker. You may have to hold the button longer, but you can see we do need to bring the second beam down and get rid of that egg shape that we have. So I'm at mirror 3 here, and we need to get that second pulse to come down. So I'm gonna use this adjustment knob here, and I need to turn it counterclockwise, just very, very slightly. So loosening the lock nut here, I'm probably going to mess that up more than I need to, but we're just gonna do our best. We're gonna loosen the lock nut. It's usually very tight. And then we're gonna loosen the adjustment knob a very, very small amount, and then try to lock that back up without messing anything up. And we're gonna verify our results. Gonna send a laser pulse through on the left side, then moving it to the right side, sending another pulse through, and it looks pretty good. So we've gone and got mirror 3 aligned. It took us a few iterations of doing some left and right tests, near and far tests, and going back and adjusting the mirror, moving it a little bit left, adjusting a little bit right. We ended up adjusting the height a little bit as well. This does take time. Have a little bit of patience. Have a lot of tape, because you might go through a lot of tape, but you will eventually get there where the near beam lands exactly where the far beam does, and then you can move on to the next step. So we're gonna move on to aligning our mirror number 4. That basically means we need to get the laser through the nozzle right in the middle. Now, to get a little bit of clearance, I'm going to lower the bed, and then just a single layer of tape, a small square, I'm going to place that over the end of the nozzle fairly securely, and then I'm going to take a permanent marker and I'm going to put a dot right on the front of that, so I know where the front is when I take it off. Now we're going to send a laser pulse through, and we're going to check how it lined up through the nozzle. The nozzle just unscrews. And then it comes off in 2 pieces, and we're focusing on the circular portion, and we're gonna hold it up by looking at the black line that we made on it, or black dot, and look through it from that view, and make sure that the dot is going perfectly through the center of the nozzle. All right, so we were actually pretty lucky with ours, and it went right through the nozzle perfectly fine. But we're still gonna walk you through how to adjust it if you needed to. So we're at mirror 4 here at the laser head, and we've placed just some pieces of tape under the nozzle so that we can see the red dot. You could place a scrap piece of wood under here too. But really, we just wanna see the red dot and what way it moves when we adjust these knobs, so that we can make sure it goes through the center of the nozzle perfectly. So let's say it went and hit off the left side of the nozzle relative to the black line that you put on there. You're going to want to move the red dot to the right to counteract the alignment of the beam going to the left. So let's say we fired the laser and it went towards the back of the nozzle and it's not going perfectly through. We're gonna want to adjust it so that the red dot actually comes down to counteract the beam firing too far to the back. So I'm gonna use the adjustment knob at the top here. I'm gonna loosen it, and you should see that red dot moving. And you don't need to move it too much, but you can see from that reference point we have there, you can see the red dot's actually coming down. And then we'd lock it in and we'd do a test. We've aligned our RF laser through mirror 1, mirror 2, mirror 3, mirror 4 through the nozzle, and it's perfectly aligned. So now what we're going to do is move on to the CO2 tube and align that based off of our RF alignment. So our goal is going to be dialing in the CO2 at mirror 1 first, and we'll continue through them all and then verify our results through each mirror. At the back of the machine here, we have our CO2 laser, and there are a few stands, one at the front and one at the back of the tube. This one at the back has 4 bolts in it, and those can be loosened to give forward and backwards movement, and those same bolts are at the front stand that you can loosen and move the tube back and forth. There's also a few set screws, one at the side of the stand, one on the other side of the tube, and those allow you to adjust the dial under the tube, which can raise it or lower it. And each of the stands at the front and back are exactly the same. Now this, we may want to do some tests before actually adjusting the tube to make sure we adjust it in the appropriate way. So we're gonna move on to mirror 1 and dial that in, and then see how the beam travels through compared to the RF, and then we'll come back here and adjust the tube as necessary. So we're at mirror 2 here, and in order to do some testing on mirror 1, we have to remove this holder again. So we're gonna undo all 4 of these bolts and pull the holder out. We're gonna go back to using our CanCam extender 9001 here. We're gonna use it to align mirror 1 for the CO2 glass tube. And we're gonna straighten out that beam path. So we're gonna put our usual few layers of tape on the proper location of the holder. So I'm gonna remove the tab, placing it over the middle, and then installing that back on. And then that is going to slide in to our holder there, and we're gonna move on to pulsing the laser. So we need to fire a pulse from the CO2 glass tube laser, and that means we need to change our settings here to select that laser for a pulse. So we're gonna do our shift focus, and then we're gonna press the pulse button and it'll send a pulse through. Checking where our first pulse landed. We can see it there. And now we're going to remove the tab, flip it over, and we'll reinstall the tool. And firing our second laser pulse at the further location on the tool, and then we'll check it. So same as all of your other alignment locations, our goal is to align the near and the far. And you can see both of our pulses are very close to the exact same location. So this would be an example of good alignment, and we don't need to make adjustments. But same as always, if you get a number 8 shape, if you're getting 2 separate circles, or if it's really oval, you may want to adjust that alignment to bring both those near and far pulses together. To adjust the alignment of our CO2 tube, we're gonna adjust mirror 1 at the base of this tool here. So your top knob here is going to adjust your left to right alignment of the laser on the machine. And then your bottom one here is going to adjust your front to back alignment. So let's say you fired your first dot and it was too far left, and you needed to bring the far dot into the right to line them up. We're going to turn this top one clockwise, and that would bring the beam along a straighter path. Once you're happy with getting your beam along a straight path using our CanCam tool, you can move on to adjusting the landing point of both lasers in this holder. So that means we may have to jump back and forth between the tube and adjust the tube a little bit, and we're going to try and match that CO2 tube to the RF, and we're going to try and leave that RF alone because we've already aligned that. So we've just made sure that our mirror 1 is along a straight beam path. So our next goal here, we're going to use this square of tape over the holder, and we're going to see where the CO2 tube lands and where the RF laser lands compared to each other. We're going to fire 1 pulse from each laser. So I'm going to do laser 1 first. So shift focus and then pulse, and I'm going to go over and check it, and then I'll come back and switch lasers and do another pulse. So here you can see where our CO2 pulse landed on the holder, on the tape. Now we're gonna walk over to the controller and fire the RF laser. We're going to switch to the RF, so shift Z plus, and then the pulse button, and we'll go and compare the 2 pulses. Okay, so we have 2 of our laser pulses here, and you can see they're not landing in the same spot, so we need to fix that. The first one on the left here of your view is the CO2, and then the smaller one on the right here is going to be your RF. And we need to bring the CO2 towards this RF laser because we've already aligned this one. So in your previous camera view, you saw that we needed to move the CO2 pulse to the right, and that's just from the camera's angle. So what that means for our tube here is we need to move it left and right at the back of the tube. Because if we do adjustments at the back, it's going to make for smaller results at the front. And with the tube, you really only want to move it a small fraction. Now, let's say in that previous camera angle, it actually needed to be moved forwards or back. That's where you would actually come in and start tilting the tube down or tilting the tube up. So tilting the tube down would cause that pulse to go further back in that view, and tilting the tube up would cause that pulse to move closer forward on that view. So we're gonna adjust our left to right here, and we'll show you how to do that. So at the back of the tube here, we're not gonna adjust the height, so we can ignore the dial and we can ignore these set screws. What we're going to adjust are these bottom 4 bolts. So at the back, we're gonna loosen those significantly, but still leave them in the stand here. Don't completely remove them. And then we're gonna go to the front stand, and we're going to loosen those, but not quite as loose as the back stand. 4 bolts at the back stand on the bottom here loosened significantly, and then the 4 bolts at the front stand loosened only slightly. Now we can pull the end of the tube towards us, because that's going to push that pulse in the proper direction. So you can do this any way you'd like, but keep in mind you want to do very small adjustments and then check the results that you get. So what I like to do so that I can feel it move is hold my hand along the side here, and then I'm going to use the hook of this Allen key to hook around the back, and I'm lightly going to do a few pulls, a few taps on the back, and try to feel with my other hand if the stand is moving towards me. And you'll add a bit more pressure each time, and then once you feel it have a slight shift, then you check your results. All right, so we've made our adjustment and we've done our test, and it's hard to see because there's quite a few layers of tape there, but both of them are lining up now. So we can tighten up the CO2 tube, and we'll do one more check to make sure that while we're tightening it, it didn't mess up. And then after that, we'll be going back to our CanCam extender tool. So continuing on with a little bit of back and forth, we've tightened up our tube. We're happy with the location for now, but we need to make sure that our mirror 1 is still causing a straight beam path. So we're gonna go back to our tool. We're gonna install this with tape on it again, and do the near pulse, and flip it over and do the far pulse. And make sure that the beam's still straight. If you need to straighten it out again, just adjust your mirror 1 a little bit at the bottom, and then we're going to continue on with some more checks with the tool to compare both lasers at the far location. So we just finished straightening out our mirror 1 beam path for our CO2 tube. If you need to see how to do that, just rewind a little bit. We've done it a few times. And now we're going to install our holder again with tape at the far location, and we're going to compare the landing of each of the laser's pulses. So you may have to switch between a few strategies of adjusting the tube, adjusting mirror 1, checking your alignment on your beam path, making sure that's straight, lining both of the laser beams up, and kind of doing what we've done a few times here repeatedly until you get it closer and closer, where even at the far location on our tool, they are landing in the exact same position, or at the very least, a very, very close position for each pulse. We're going to install our mirror 2 mirror holder back on the stand there, and put the bolts back in. We've just installed our mirror 2 holder back onto the stand, so we're going to move on to testing the near and far locations of the space between mirror 2 and mirror 3 for each of our lasers. So we're going to install some tape over our mirror 3, and we're going to test our alignment similar to as we did earlier in the video when we were just doing the RF laser by itself. So we've just fired both of our lasers, a near and a far pulse, and you can see they're landing in the same spot here. So that is an expectation we have because we've already aligned these mirrors when we just did the RF by itself, so we're expecting it to be good. And we've aligned the CO2 earlier at mirror 1 through mirror 2 with the RF. So if we did a good job there and they're matching at the beginning, they should match throughout the rest of the system. So if you're finding your alignment still a little bit off or a lot off at the mirror 3 holder here when you're doing your near and far pulses, it's likely that you need to go back a step and adjust your CO2 tube a little bit further and do some more tests with that CanCam extender tool again. Just a small disclaimer here. It's possible that the mirror 2 holder, when you're uninstalling the 4 bolts and taking the holder out and reinstalling that it has some wiggle to it. So your alignment may be fine, but it's a case of you've installed the mirror a little twisted. So you may see something like that as you have the near and far beams, they're not matching, but your near CO2 and your near RF pulse is hitting in the same spot, and your far CO2 as well as RF pulse are hitting in the same spot. Typically that would be a left to right difference between the near and far. It's likely your holder is just twisted down here. So there is a little bit of wiggle you can see in that. And you can either adjust this, or if you want to adjust the mirror you can, but I'd recommend if it's just a little bit of left and right issue, then you can just figure out which side is the better aligned angle. All right, same as earlier, we're at our mirror 4 here, and we're adjusting our mirror 3 to check that alignment. So a little piece of tape over this, and we're gonna do our near and our far tests to check the RF versus the CO2 location. So the CO2 alignment is good, near and far line up perfectly, and they're going through this opening. So we're good there. We're just gonna check the RF now. So our near and far for our CO2 is good, and then we just did the RF over without moving the tape, and the RF is landing near and far in the same location as well. Now the RF is only a 30-watt laser here, so it's not going to appear as nicely as the CO2, but when watching it I could see that it landed in the same spot near and far. Now it is off a little bit to the right compared to the CO2, so we could bring the CO2 a little bit closer in, and this is done by actually going back to the tube and either tilting it up, down, left, or right. Now, determining that angle, you just got to trace the beam path back, and we'll describe exactly what we would do to get the CO2 to the right so that it's perfectly in line with the RF. The results we just got in the previous scene are very close to perfect, so I would actually recommend if you get one similar to this and all the beams are going through that opening, then I'd recommend not actually making these adjustments. But let's say it was actually a little far out of the holder, it's hitting the side of the frame at the nozzle in front of mirror 4, then you'd want to come back to the tube and make a very, very, very small adjustment. So how this works is actually your left and your right adjustments at the location in the previous scene, mirror 4, to move those beam landing locations, you would actually move the tube down to cause the beam path of the CO2 to go to the left, and if you moved the front, the nose of the CO2 tube up, that would move your CO2 beam path to the right, and then moving your tube left and right here affects your up and down landing position at mirror 4. So what I'd recommend, similar to before when adjusting your tube, is do all your adjustments at the back stand. So ours, we needed to move the CO2 a little bit to the right. So what I would do is I would actually lower the back stand a very, very small amount. And what that would do is if you lower the back, that actually raises the angle of the front of the tube up. To make this adjustment, you would loosen the set screws. There's 2 on this side and 2 on the back. And then you would adjust the knob, and that would raise and lower it, and then lock it back in. All right, so our final tests are going to be done at the nozzle and mirror 4 here. And we've already done this with the RF, so if everything's lining up before mirror 4, then it really shouldn't need adjustment. It should, all of the lasers should be going through the nozzle perfectly fine, but we're still gonna verify that as our final test. So a small piece of tape, just like before, over the end, and then take a permanent marker and put a little dot on the front. So I just pulsed the CO2 laser first, and I'm gonna check that by itself. And then I'll check the RF after. So finding that black dot on our nozzle, we're gonna then tilt up from there, and we'll look, and it looks pretty centered to me, so our CO2 is perfect. So doing the same procedure for the RF laser, I've put the nozzle back on, I've put a piece of tape over it, and I'm gonna use a permanent marker again, do another little dot, and then close it up and send a pulse through with the RF. So just taking the nozzle off after we fired the RF, and we'll see how our results turned out. All right, so finding that black line and tilting back, and it is going through the nozzle. It's a little bit off, but it's completely going through and not hitting the edge, so I think we're pretty good. So if you need to make any adjustments to your beam path through your nozzle, just look a little bit further back in our video. We did that procedure for the RF earlier, and just keep in mind you're now moving the mirror and it's affecting 2 of the lasers. So don't move it too far, because one of them might go out if you get the other one in. And if that's the case, where you're getting one is out and the other one's in the circle, then that means you've made a mistake earlier, and you need to go back maybe 1 step and check your alignment there. Now moving forward, earlier in the video we mentioned a small square of acrylic. We're going to cover this in our next video on squaring up your laser head so you can cut thick materials with perfectly squared edges at the right angle. So stay tuned for that, it's on the way, and yeah, we'll use this in the next one. Thank you for joining us for our Super Nova 14 alignment video. If you need any additional support or parts, or you have any questions, you can reach out to our support team at support@cancam.ca, and we can help you out.